So you're back from a nice long weekend that you guys had. We had grading to do. I think I figured out that I had 14 hours of grading to do after that whole thing. So I really regret not having a multiple choice final. Oh, it's so painful to grade the other kind, and there's so many of them, and they're really important. So anyway, bottom line, we're back, and we're back into this kind of thing. 2, 5, blank. Well, didn't we do that before break? Yeah, but we did half the chapter. That was chapter 9. And do you get this next number? Could be 2 different things. Because it could be either arithmetic or geometric. All right, so arithmetic is the kind where you're adding, or even adding a negative number. Either way, it's considered adding. Or the geometric kind is where you're multiplying by something. All right, so let's call this the arithmetic kind and the geo kind. One of them is super easy to do in your head, one's not. I want you to talk through what you think would be here and here with the kid next to you. And when you're talking to that kid next to you, I want to make sure you get their first and last name. Write it down so you can memorize it. I'm sitting next to John Smith or whoever it is. And I want you to know one thing about them. Okay, so like it might be like I am hardcore into chess, or I play video games until my fingers bleed, or whatever it is. Okay, so talk to the person next to you, find out those 2 things, and see what they think the answers would be if it's arithmetic or if it's geometric. I'll pause while you guys get to know each other a little bit, and I'll make sure you know who you're paired with. We're back, and I'm hoping you knew that if it's arithmetic, then you're just adding 3, and so this is an 8. And if it's geometric, though, it's a little more tricky. You got to figure out that it's 5 divided by 2 was what's called the common ratio. So if you multiply by 5 over 2 each time, you get the next answer. So if I do this, it's going to be 5 over 1. So that's going to be 25 over 2, aka 12.5. I totally like 25 over 2 better, but I'm going to put both. Raise your hand if you had those answers. You with me so far? Okay, any questions? All right, so why are we talking about this again? Because we have to know everything from that first part of the chapter for our test. Your test has the same stuff on it. You know that quiz you took? Same stuff on the next test. So if you struggled on that, we got to get the stuff down, and tomorrow I teach you new stuff. Let me get into actually a little glimpse of tomorrow. You know in the past where I'd say this is like from 1 to 3 and this is 2n plus 7? Do you guys remember a few things about this? Like that's a what Greek letter? Sigma. So that went from 1 to 3, and that means you put in the 1 first, and then you get 9. Do you get how I got the 9 as the first term? Does that make sense? Okay, now what if we went to infinity? Would that even make sense? Well, there's converging sequences and diverging sequences. If I just keep going, I'm just going to add, I put in a 2 next, and I get 4, and 7 plus 4 is 11, and then you start realizing, oh, I'm just adding 2 each time because of that 2. 9, 11, 13, and then, could you really add these all up? I mean, really, doesn't it just keep getting bigger? Every time you do another one, it gets bigger. So can you add this up? No, you can't. But can you add up some sequences? Yes, because they're like this. What if I had a whole piece of cardboard? And I said, first, color in half of it. Would you agree that that is a doable task? Half of it. Then what if I said, 1/2, color in a quarter of it and add that to it? You know, like add it, like the summation thing, and I color in a quarter of it. Do you get now I've colored in this much? What would the next logical thing after 1/2, 1/4, what would be next after that? 1/8. Do you get 1/8 of this thing is like that big? That's 1/8 of the whole thing. Do you get that if I just keep going like this, I will not shade in the whole piece of cardboard? You won't end up shading in the whole piece of cardboard, okay? But you will end up getting some finite amount of cardboard shaded in. It won't shade in everything, but it'll shade in some finite amount. And if I just kept going and just kept going and just kept going, it's going to be less than the whole piece of cardboard that gets shaded in. And yet, weirdly, an infinite number of pieces can be added up to a whole. So here we go. This is a geometric or is it a arithmetic? This one's geometric. So geometrics are the only kind that can get added up. And you have to be multiplying by a fraction, getting smaller, smaller, smaller. That's the only kind. So their R value, do you get how this R value is the common ratio? I was multiplying by a half every time. My R was a half. If you multiply by something less than 1, then, and only in that situation, you can get an actual answer. And I'll show you how this applies in the real world too, so it isn't just all like esoteric stuff. This affects you every day, believe it or not, that you can add an infinite number of things and you can get a whole number out of an infinite number of things. And it's so weird. If you don't understand why it's weird, then you don't really get it. How could you add an infinite number of things and get a whole number? It's weird, but it's true. So I'll teach you that tomorrow. So what do I need to teach you for the rest of the day? Well, the hardest kind, I think, were when I gave you, well, actually, not even the hardest. This is a medium hard one. When I gave you a sequence like 2 times 3 is 6, times 3 is 18, ... and you had to make me one of these. Let's say we do the first 10 terms. Can you make me the sigma for that? I'm going to pause for a second, and I'm going to remind you that the formulas, they're up on the board here. Now, in some of your classes, like, I'm not certain, but I know that Mrs. Roach's kids learned it with this formula, the n and the a plus a sub n over 2. And I don't know if Mr. Whitcomb's kids did the same thing. Which of you guys that are new came from Mr. Whitcomb's classes? All right, did you use this one? Does that ring a bell? Okay. How about Mrs. Roach's kids? Who is Mrs. Roach's former? Okay, thank you. Do you guys recognize that one? Okay, you guys for sure use that. Okay. So I want you to know that this one and this one are the same thing. I'm referring to formulas that are on my board in my room here. But you won't use either one of them to make this right here. You're going to use what I call the term finder. And for arithmetic ones, it's one thing, and for geometric, it's another. So here's the arithmetic kind. A sub n equals a plus n minus 1 times d. That's the term finder for arithmetic. For geometric, the term finder is that one you see on the board. A sub n is a times r to the n minus 1. Well, use the right one and figure out what to put here and here and here to make the sigma for this problem where we get the first 10 terms. That's a medium hard one. The hardest kind we'll actually tackle tomorrow. But, all right, I'm going to pause while you work on that one. Compare with the kid next to you, by the way. Okay. At this point, there was a lot of kids that never said anything, but I don't know, did you already compare? If you haven't already, talk and see what your answer looks like compared to theirs. Okay, so here's how I'd do it. I would take, and always put a 1 there. Just always. Always start with a 1 there. And if I want the first 10 terms, put the 10 here. Then I would take that term finder, and since this one is a geometric, that's this, and I put that right here. A times r to the n minus 1. And then I fill in what I know. I know A. I know our starting term. It's right there. It's a 2. So that 2 goes right here. Okay. I'm just sticking numbers in a formula. It's not that hard. Do you know the r? Sure, it's the thing you multiply by each time. What do you multiply by each time? 3. So that's r's a 3, and that goes here. And then it's to the n minus 1. But you don't put anything in for n because you need a variable. That's what these numbers are for. They go in the variable. Now, just for the fun of it, how would you find the 7th term? Yes. Just stick in a 7. So 7 minus 1 is 6, and this would be 3 to the 6, which would be a pain. It'd be huge. And then you times it by 2, and you got your answer. Okay, so if you've got a formula like that, it's super powerful. If I want the 7th term, I just stick in a 7. How is that different than this? Starting this time with 10 and adding 4 each time. What if I want to find the 7th term of this? Well, use the term finder. We just talked about them. I just showed you both of them. Use the appropriate term finder and find me the 10th term. Don't just do it by hand where you just keep adding 4 a bunch of times, because we're not going to ask you for the 10th one. On the test, we usually say, like, what's the 73rd term? Because you're going to have a calculator on this next test. So you'll have to know how to put these into a calculator. Calculators will be allowed for this coming test. All right, so try to figure out what the 10th term would be. Use the right term finder. Since I want the 10th term, use the term finder. I'll pause while you give that a shot. Okay, let's see how you did. You add 4 each time, right? So that's the D. That's called the common difference. And what term do we want? 10th. So we put a 10 where the N is. And this is A sub 10. That's what you call the 10th term, is A sub 10. Now we can figure out what the answer is by putting A, which is 10, right there. And then this is 9 times 4 is 36 plus another 10. 46. A sub 10 is 46. Raise your hand if you had that one right. Okay, cool. All right, good. Here's a little review of how to use those formulas. Is that everything? Nope. But it's enough for today that you'll be able to rock this worksheet. It's a Schoology quiz. I'd like it all to open it up right now. And I'm pretty confident by the end of the hour you'll be done with your first homework assignment and have probably an A going already. All right, so please open up the Schoology quiz. I can see who's got it open and who doesn't. The last hour, one kid had sat through the whole hour and hadn't even opened it. I went over and talked to them, and they said, I thought I did it. Like, they did a Schoology quiz, they just didn't know the right one. Okay, so just everybody get in there right now, and then I'll look quick and make sure you're doing the right one.